Over here we have an ellipse graphed, and what we want to do is come up with the equation of this ellipse, but we're going to do it in steps. The first thing we want to do is figure out the center of this ellipse, and if you are so inspired, think about where that center is. All right, so if we think about the x-coordinate of the center, we can see that the ellipse goes from x equals -4 to x equals 8. And so the x-coordinate of the center should be right in between. So this is from -4 to 8 is a total of 12. So if we go 6 from either side, half of 12, then that will be the x-coordinate of the center. So 6 to the right of -4 would put us at 2, and 2 is also 6 to the left of 8. So that would be our x-coordinate of the center. And then the y-coordinate of the center, we see that our y values for this ellipse go from 1 to 7. So it goes a total of 6, or our change in y is 6 from both of these extremes. So if we were to go 3 from the bottom or 3 from the top, that would be the center from a y perspective. So 1, 2, 3, right over here at y equals 4. So the center here is x equals 2 and y equals 4. Now the next thing we want to figure out, and we've already actually talked about this a little bit, is what is the minor radius, or sometimes called the semi-minor axis. Well, these are very fancy words. We know if we think about a circle, you only have one radius, but an ellipse, you can think about where does the radius hit a minimum and where does the radius hit a maximum. And when we're talking about the minor radius, we're talking about the minimum radius right over here. So from the center to say this point over here, we already figured out that that is 3. We could have also gone from the center to that point there. And then some people will also call that the length of the semi-minor axis. Now we could do the same for the major radius. That is the longest radius that we have in this ellipse. Let me do that in blue. So that would be from the center all the way out here, and we already figured out that that length is 6. So now we have all of the information we need for the equation of this ellipse. When we express it, we could write, let me write it this way. First, we think about x. So x minus the coordinate of the x center, so x minus 2 squared, over the radius that is in the direction of the x. In this case, we have the major radius that is in the direction that is in the, I guess we could say the x direction. So that is over that squared. So that's where that 36 comes from. And then plus, if we think about the y values, it's going to be y, or the, I guess, y part of the equation, y minus the y coordinate of the center, squared, and then all of that over, in this case, our semi-minor, the length of our semi-minor axis, or our minor radius, squared, so that's 9, is equal to 1. And in other videos, we have actually proved where this comes from. But this is just a way for you to recognize if you know the center and you know the minor and major radii, then you can figure out the equation of the ellipse.